Okay, so now we're going to talk about scalars and vectors. This is very important to understand for the rest of the lessons. Now, a scalar quantity is a quantity with only a magnitude, which means a value. Okay, so only what? Only a value or a magnitude. So, but a vector quantity is a quantity with both magnitude and directions. Now, what are these? So we've got, for the scalar quantities, we've got distance, speed, energy, work, power, pressure, mass, time, and charge. You've got displacement, velocity, acceleration, force, moment, and momentum in the vectors. Now let's see the difference between, for example, one of the most famous is distance and displacement. Now distance is the actual path covered. Displacement is the certain is the certain distance covered relative to a fixed point. So look at this. You've got an object that started at A and finished at B. So that shortest path is the displacement, but actually the object went through all this distance to reach this point. So that is distance and that is the displacement, okay? You also got speed and velocity. We're going to go through that for now. But look at this example. So you've got this object or this car moved 100 kilometers to the right and then it returned 40 kilometers. Now, total distance is the 100 plus 40. So there is no change in that. So it's 140 kilometers. But if you go to the right, that's the positive direction. If you go back to the negative, that is what we call a direction. So when it's a direction, it takes a positive sign or a negative sign. Usually in physics, we take right as positive and left as negative, up as positive, and down as negative as you go through the syllabus. Okay, now let's take more in details example. So let's say you are an elevator. So you go into the first 0 floor, which is the ground. You go up to the first and then to the second, and then you go back to the first again. So in order to calculate the distance and the displacement, so let's see how is that going to be. So the distance is you just basically adding up. So 3 and plus 3, that is 6, plus 3 again, that is 9. So that is 9 meters, okay? But for the displacement, you go up plus 3 and then again plus 3 and then you go down a negative 3. So your total displacement is basically positive 3 meters, okay? So that is the difference between distance and displacement when you're going vertically. So let's look at the horizontal idea. So let's say an object was at A, moved to B, and then to C, and then it went back to A. Okay, so that is the motion. So in order to get the distance, as we said, you just add it up. So that would be 5 plus 10, and then he's gonna go back 10 and another 5. So that would be actually 13 kilometers. Now for the displacement, it's just positive 5, positive 10, minus 10, minus 5. So that the displacement is 0 kilometers in total. And that's the difference between what distance and displacement. Okay, now let's look at the difference between velocity and speed. So for example, this car was moving to the right with 100 meters per second, and then it changed its direction and went back with a 40 meters per second. So to get the change in speed, it's basically it was going right to positive 100 and then it was back with a negative 40. When you get change, the idea of the word change, which is delta x means x2 minus x1. So in this case, it's delta v. So that is v2 minus v1. You simply get the 60. So that was 100 minus 40, and therefore you get what? 60 meters per second. But for this example, if we're gonna do it in terms of velocity, so you have this one was going to the right with a 100 meters per second, and then it turned back with a negative 40. So that would be negative 40, and there's a negative in the equation, so that is a negative 100. So that is negative 140 meters per second, and that is the change in velocity. That's the difference between velocity and speed, is with respect to the sign. Okay, thank you for listening.